Good morning to one and all. My name is Rajesh, and today's session I'll be explaining the concept on microscopy. The microscope is an instrument used to see objects that are too small to be seen by the naked eye. There are many types of microscope, and most common microscope used are optical microscope, electron microscope, and scanning probe microscope. The, the optical microscope, which uses light to pass through a sample to produce an image. Electron microscope uses electron beam to pass through a sample to produce an image. Example, scanning electron microscope. Scanning probe microscope uses probe. The probe is scanned over the surface of the sample, and the forces that causes an interaction between the probe and the surface of the samples are measured and mapped to produce an image. Example is atomic force microscope. So coming to the first type of microscope, that is optical microscope, you can see the image of a compound optical microscopes. Optical microscope, it's a type of microscope which uses visible light and a system of lenses to magnify image of small samples, and it consists of basic components. The basic components is a eyepiece lens. The eyepiece lens, the eyepiece lens, which is used to let to see the magnified image of the specimen in clear detail. Next, objective lens. Objective lens are of three types. They magnify the specimen 4, 10, and 40 times its actual size. The three lenses are attached to a revolving disc, make it easy to switch between the lenses. And the figure, as you see, the compound microscope magnifies a object in two stage, that is light from the mirror. You can see here the light which is being used, the light from the mirror is being reflected up through the specimen or an object to be viewed into the powerful objective lens, which produces the first magnification. The image produced by the objective lens is then magnified again by the eyepiece lens, which acts as a simple magnifying glass. The magnified image can be seen by looking into the eyepiece lens. The viewer will be seeing here, and he looks on the eyepiece lens, and thereby whatever the image based upon the magnification that is being set will be obtained in the eyepiece lens. The pivot which is being used here, the pivot lets the person using the microscope set it at the best angle for viewing. For viewing purpose, he can adjust. Next, the tube where the tube is being used, where the light passes through the tube from the objective lens to the eyepiece. So that this is the working principle of an optical microscope, and the main purpose in which it is used here. It can be extensively used in microelectronics, material science and geology, non-transparent objects, example metals and alloys, biotechnology, for analyzing transparent objects, in microbiology and many other sampling testings, where you can obtain the microscopic image of an object. So here I have represented x50, means image viewed will appear 50 times its actual size, and another figure B indicates where you can see the grain boundaries and grain size of a sample. So this is the grain boundary, and this represent the grain size of the samples. By using the optical microscope, one can view the sample surface, whereby obtaining grain boundaries and grain size of the specimen, which cannot be seen by our naked eye. And another uh, microscope which I am going to explain is on scanning electron microscope. The scanning electron microscope is a microscope where it uses electron beam to image the samples with this resolution down to nanometer scale. The main SEM components includes electron gun, lens. The lens can be of two types. One is condenser lens and objective lens. Sample chamber, this is the sample chamber. Electron detectors, there are three types of electron detectors: backscatter electron detector, secondary electron detector, and X-ray detector. Next, computer and display to view the images. So the computer will be there, so whatever the detector detects, that will be converted in the form of an image and will be seen in the computer. So whatever the uh, chamber in which the SEM works, it will be operated in vacuum systems. Both the column and the chamber are evacuated by a combination of pumps to operate at low vacuums. This allows the passage of electrons through the column without the interference of air molecules. So whatever the beam that is been passing from the electron gun to the samples, that will be maintained with free air molecules. So there will be no interaction between the air molecules because whole system is being maintained with a vacuum chamber or vacuum. So the working principle behind SEM is been explained like this. The scanning electron microscope produce images by scanning the sample with a high energy beam of electrons. The electron gun is used to provide a stable source of primary electrons. The electron gun uses a filament which is made from a bent piece of wire size nearly 100 micron diameter. A current is applied to the filament to heat the wire to around 2700 Kelvin. If a filament is a tungsten, at that point the electrons are emitted. You can see here when it is been heated, the filament is been heated at around a temperature of 2700 degree Kelvin. If the filament is a tungsten, then the electrons are emitted from the filament. So electron produced are accelerated down and pass through a combination of lens and apertures to produce a focused beam of electrons which hits the surface of the sample. And you can see here the main role of a condenser lens is to control the size of the beam, and the optical or objective lens which is used for focusing at different working distances. The electron beam passes through the apertures. So the aperture is used to control the number of electrons which reach the samples. So, and the deflector coil, you can see here the deflector coils which is being used, which is nearer to the objective lens, they are used to raster the electron beam, that is to deflect the beam in x and y direction so that it scans in a raster fashion over the surface. Next, when the electron beam hits the surface of the sample, it penetrates the sample to a depth of a few microns depending on the accelerating voltage and the density of the sample. As a result of the electron sample interaction, a number of signals are produced, and here three types of signals are being produced. First one is secondary electron images, backscattered electron images, and elemental X-ray maps are being obtained in the SEM process. So how it will be obtained? So when the beam strikes on the surface, one of the images that will be obtained will be at backscattered electron detector when the beam reflects back. When the beam reflects back, the electrons will be captured by using backscattered electron detector. Next, when the beam strikes, it will be scattered over the surface. That scattered beam will be recorded by the secondary electron detector. Next, when the beam strikes on this sample, it go beneath the sample surface, and where the X-ray will be developed, and that X-ray will be recorded in the X-ray detector. So by using all the three images, that is secondary electron images, backscattered electron images, elementary X-ray maps, one can able to get the dot by dot, row by row, an image of the original object is scanned onto a monitor for viewing. So the image obtained is used for examination and analysis of the microstructure morphology. By using secondary electron images and backscattered electron images, one can able to get the microstructure morphology, and by using the elemental X-ray maps, one can able to check the chemical composition characterization of an sample. So the video in which I'm going to represent is a scanning electron microscope. How you can see the working principle behind the scanning electron microscope, where you can see the electron gun. From the electron gun, the beam is being made to flow through a lens, and through the lens it will be made to pass through the samples. And here by using the deflector coils, the movement of beam will be in x and y direction, and that rays in which it will be developed. Here it is showing the secondary electrons, and that secondary electrons will be recorded in secondary detector. You can see the computer screen where the images is been forming. The surface morphology of a sample is being recorded in the computer screen. So the movement of the samples or the movement of the beam will be made so that the clear image of a sample will be recorded in the computer screen. Next, also we discussed that the beam emits X-rays, so that X-ray will be recorded in X-ray detectors. So by scanning once again the beam and detecting the X-ray energy, one can deduce the chemical nature of the material and its spatial variation. So one can able to go for chemical analysis part by using this X-rays. So that is how the SCM works. So it is mainly used for surface morphology, and also it is used for checking the chemical composition of an element that is being used. Next type of microscope in which I want to explain is scanning probe microscopy. The scanning probe microscopy is an instrument used for studying surface at the nanoscale level. You can see the working principle of a scanning probe microscope. The figure represent a basic working principle of SPM, that is scanning probe microscope, while probe is in contact with the sample and the probe is attached to the beam, where the beam can move up and down by the support of the bar. A feedback mechanism is used to maintain the tip at a constant height above the sample. A piezoelectric scanner which moves the sample under the tip in a raster pattern. So this is the raster pattern in which the movement of the sample takes place by the use of piezoelectric scanner, and a computer system that drives the scanner measures the data and converts the data into an image. So this is the concept of a scanning probe microscope, and example for this is a atomic force microscopy. And why it differs, why scanning probe microscopy differs with other microscopy means there is not necessary of any focusing light or electron beam is used for getting the image. SPM uses no lenses but rather a probe that interacts with the sample surface. It physically feels that sample surface with a sharp probe, building up a map of a height of sample's surface. So as I told, the example is atomic force microscopy. The image what I have represented here is atomic force causing bending of cantilever. See, this is the cantilever beam and this is the probe and this is the sample surface. When atomic force is being applied on the cantilever, what happens? The cantilever will bend. So that by using that bending nature, one can able to get the surface morphology of a samples. So that will be explained uh, by this working principle of atomic force microscopy. So the atomic force microscopy, what as already said that the atomic force microscopy, why it is used, it is an instrument for the study of surface properties of both conductive and non-conductive samples. So how it will be done? So you can see here there is three step of working is carried out in AFM. First one is surface sensing, and AFM uses a cantilever with a very sharp tip to scan over a sample surface. As the tip approaches the surface, the close range attractive force between the surface and the tip causes the cantilever to deflect towards the surface. You can see the deflection in which the cantilever has been taken place based upon the sample and probe interaction. So next one is a detection method. So how the detection method is done? The laser beam is used to detect the cantilever deflection towards or away from the surface by reflecting an incident beam on of the flat top of the cantilever. The raised and lowered features on the sample surface influence the deflection of the cantilever, which is being monitored by the position sensitive photodiode. Next is by using the feedback mechanism. By using the feedback mechanism, it is used to maintain the tip at a constant height above the sample. A piezoelectric scanner is used which moves the sample under the tip in a raster pattern. The computer system that drives the scanners measures the data and converts the data into an image. And the purpose of using AFM is to generate an accurate topographic map of the surface features. So the video representing the atomic force microscope. Here you can see here the sample has been placed here and the cantilever which has been attached with the probe, and the photosensitive diode has been placed here. A laser beam strikes on the cantilever's top surface and the photodiode detects the movement of the beams, and based upon that in the monitor the surface morphology has been recorded. So that is how the working of atomic force microscope works on to get a 3D image of an object. See here, movement of a cantilever which is attached to a probe gets the image on the screen. So that is the concept of AFM. Also used by using the force that is been acted or acting on the tip on the surface, the image will be obtained. So comparison of AFM and SEM. So when we compare between the two, based upon these parameters, we compare sample preparation. For AFM, there is not necessary of sample preparation has to be done. Whereas when it comes to SEM, the sample preparation is required. The resolution of AFM is around zero point 0.1 nanometer, whereas in SEM it is 5 nanometer. And relative cost, AFM is low, whereas in SEM it is high. And the sample environment in which AFM works can be of any environment, whereas in SEM it is necessary to operate at vacuum or a gas chamber. And the sample type which is used in AFM is of conductive or insulating, whereas in SEM it should be a conductive in nature. And the time for image to obtain in AFM is 2 to 5 minutes, whereas in SEM it can obtain the image at zero point 0.1 to 1 minute. Measurements in which the AFM obtain the images can be of 3-dimensional, whereas in SEM it is 2-dimensional. Maximum sample size that has been obtained in AFM is unlimited, whereas in SEM it is 30 mm. So we discussed about three types of microscope, that is optical microscope, uh, scanning electron microscope, and atomic force microscope, where each one utilizes its own working principle. That is, optical microscope uses the light as a source for obtaining the images, whereas the scanning electron microscope utilizes uh, electron beam as the source to obtain the images, whereas the AFM utilizes the atomic force, and by using the probe which is in contact with the surface sample will get the images of the required nature. So that is what I wanted to explain about this concept of microscopy. Thank you very much.